Hello, everybody. Today's video is going to be about making AI music, and we're not here to make some ethical judgments about what it is. I'm just going to teach you guys how to do so. And if you didn't notice, for my previous video, which was about bypassing the Spotify API, I actually used, for the background music, I used AI lo-fi, meaning that the tracks were not made by a human, but rather AI generated. So I didn't actually AI generate them. They were on this platform that tags certain songs as being AI generated. So I used those. And it got me into a rabbit hole about finding out how I could do that for myself. So here and today, I'll be teaching you how to do something similar to that. Now, we're going to be pulling out the AI rig from many months ago. This has undergone some changes, but it's kind of also still the same. And I'll walk you guys through start to finish about how to kind of get this all set up. And yeah, it's not going to be too much of a face-to-face video today. It's going to be mostly on the computer. So yeah, let's get started, guys. Okay, so here I am on my computer. Now, this is this comes from Google Colab research document that's on the official GitHub. So we'll be using AudioGen or AudioCraft as well as what's also called by Facebook /Meta. So let's get started. So first, let me get to the actual thing, which is where it is. It's going to be in a collab, and I'll put this in the description. It's also linked in the GitHub. Oh, it might not be here. So let's go to github.com/ or if we just search AudioGen, Facebook. It's also called AudioCraft. So let's go here. And if you go to, so this is going to be the actual project. And we have right somewhere. It should be, if we do, so we'll be using music? No, AudioGen, not Music Gen. And we won't be using through the Torch Audio, because this is kind of more deterministic. We can write down in code how everything works. So I'm going to assume that you guys, we can do this in a collab research as well. So let's SSH into my server, my AI server. So let's connect in. Cool. So to check the specs, to show you what the specs are, I'm going to run fast fetch on this. So you can see it's going to be running Fedora server. It's going to be using a Ryzen 7 2700X, 8 threads and 8 cores. And we have the 2070. So if we do NVIDIA SMI, you can see for the NVIDIA, it's going to be 8 gigs of VRAM, the 2070 here. So yeah, and I already have it set up. So, but because we want to start from the start, I'm going to show you. So this is the GitHub I'm using. It's just a fork of it. And what it's able to do is it has a Gradle instance, and that Gradle instance means that you can just use it. You don't have to do any port forwarding. You don't have to write any code. This is codeless. So let's go here and let's start over. So if we do, let's create a Conda environment. So we're going to use, and I'm going to assume that you guys have Miniconda installed. If you don't, go look at my Comfy UI tutorial. There it has the Anaconda set up. So we're going to create a new environment, and let's just call this audio generation. So it's going to create that. And then we're going to say yeah, and then now let's activate it. So this was something that I didn't do in my other video about the the Comfy UI video, but you're gonna have to make sure to install. That's why everything was saying for the previous or that video that all my dependencies were installed. But what you need to do is going to be conda install Python, and then we want to set the version. If you look at the README here, it's going to say we want 3.9, so we're going to set that to 3.9. And now it's just going to run through, and it's going to keep going. So it shouldn't take that long. There we go. So if we can check, if we do python -s version, we should see that's 3.9, which is different because if I did conda deactivate, so I go out of this virtual environment and I do python -s version, it should be different. Yep, 3.13, that's the latest. So that's why conda is such a useful tool. You want to make sure. So let's just clone this. And remember, we're on the BG branch. The BG branch has the app.py here. That's what we want to use. So let's do git clone -b, and then B stands for branch, and we're going to be using the BG branch of this. And let's output it to a folder called audio. So now we're in, and then we can see everything's there, including that app.py. And yeah, so all we need to do is install all the dependencies. So you're just going to run pip install -r requirements.txt, and then it's going to download all that. And well, it's already cached, meaning because I ran through this before. But yeah, just let it do its thing. And yeah, I'm going to speed it up now. And we're back. Okay, so now we have all the dependencies installed, so we shouldn't really have to do anything else. Also, another thing that you must know is you need ffmpeg. For Fedora, you can just install it like this, like that. Log in, and yeah, we're already installed. So we have ffmpeg here, and then now we can just run python app.py, and then we do the -- share. So we're gonna add that flag. And then what this will basically do is it's going to generate a Gradio link, and Gradio is just an interface that we can use to access it. So it's going to get a public space. So that means we don't have to do any firewalls, we don't have to do any port forwarding, and messing around with what the host is. So we can literally just copy this. It's going to be for 72 hours. So if you try to access it after this video, it's not going to be on. But let's go there. And then what we'll immediately see is our configuration. So there are two types of models. You have the melody model, and what that will say is you can describe, and then you can also have a melody that it's going to try to adhere to. But if for like people like me, if we're just using lo-fi, for example, we're just going to do the medium, small, or large. And generally speaking, this just refers to the amount of parameters it has, and the larger the model is, the more VRAM it will occupy. I actually found that for 8 gigs of VRAM, you can actually do a medium and set the duration to 120 seconds. Now that's going to take long, but it really doesn't matter. And then for these, you kind of don't need to change them. They just represent some other tunable configurations. If you want, you can read the paper or read the repository. Temperatures like randomness, classifier free guidance is kind of how free is it able to express itself. Is it going to be really strict? And then your seed is obviously going to be like you're determining for the randomness, because obviously it's going to be a little random. So let's run some input text, and a way to do that is if you go to like ChatGPT or Gemini, and you can see I've already did a little bit here. If you do generate a description for lo-fi that I can use in my audio gen by Meta, it's going to give us a nice prompt that we can use. And this is a common tactic throughout everything. You can use AIs to generate prompts for you and then put those prompts in. So let's put that in here. And then what we're going to do is, let's just set it to 30 seconds because 10 seconds is still a little too slow. And then let's just press generate. So what it needs to do first is, because we just cloned it, it needs to download the model. So you're going to wait for a second here, and then obviously I'm going to have to speed up that video once it starts downloading. So give it a minute. So you can see here it has the configuration. We have a segment, duration of 30 seconds. We have 5 overlaps. So it's going to be running now. Oh, so actually, because I already cloned it, they already have the model downloaded. It's in probably a common place. So we're actually just going through it now. And then if I go in and show you what the NVIDIA thing looks like. So if we do the watch-n 0.5 NVIDIA SMI, we can see that it's using about 5 gigs of VRAM here. And it's going about, 80 watts of power. So it actually isn't too bad. So we're gonna keep going it through, and then yeah, we can just wait. It's pretty fast. Obviously, the longer your duration is going to be, the longer it's going to take. For example, when I was doing testing, about a 2 minute, so 120 seconds. It takes about maybe 3 to 4 minutes to generate. And obviously, it's going to be really dependent on your hardware. And yeah, so let's go through here. And we're almost there. See, this one's not that slow because we made it really short. So at this point, it's going to start encoding it. We can see here, and it's really quick to encode. Obviously, the longer the duration, the harder or the longer it'll take to encode. And then yeah, I'm going to press it in 3, 2, 1. And so yeah, you can hear it sounds like lo-fi. It sounds pretty chill. And I mean, it obviously isn't perfect. You can tune these parameters. The larger the model, the better it's going to sound, obviously. But for some consumer grade hardware like I'm using, right, a 2070, 8 gigs of VRAM, it's not too bad. And I will actually show you how we can, if you don't have this type of hardware that you can run on your own device. Yeah, that's literally it. It's not that hard. And I might use this type of music going forward for my background music, obviously, right? We have to consider the ethical changes or the ethical obligations here. But the fact of the matter is that it works. And yeah, I'm going to show now, if you don't have, say, like a powerful server or computer at all, but you still want to try this, you can just use Google Colab. So let me stop this. So if we go here and cancel, so let me download this before. I shouldn't have canceled it, because then now, oops, I forgot to download. Uh-oh. It's fine. Yeah. So let's do this exact same thing. If we go to colab.research.google.com, so what Google Colab is it's a research platform where you can access some decent hardware stuff for free. Obviously, you can make it cost money, but generally it's free. So when we're here, we want to say, number one, we have to create a notebook, and then we want to check the runtime type we're going to be using. So you don't want to use CPU because CPU is slow, and then we should use T4 GPU instead of this, because this is a TPU. A GPU and a TPU are different. A TPU is a tensor processing unit, and it's specialized for AI applications, but I'm not sure whether or not Meta has like coded it to use TPU. I'm assuming it uses GPU because Meta has a fuck ton of GPUs. So let's set that here. And then here we can write any Python code at all. So like, for example, we can import, we can print, but for the most part, we actually don't need to do that because we're literally we can also run shell commands. And the way to run shell commands is you can do the % in front of it. So if for example, if I do % echo hello world, it's going to run that as a shell command. So it's connecting right now, as you can see in the corner. Oops. Well, that's embarrassing. But they do have like, is it %? I think it was %, right? %git. Wait. Oopsie daisy. Oh, wait. Running commands in Jupyter Notebook. Is it %? It is %. Oh, it's exclamation mark. Sorry guys, it's exclamation mark. So if we do echo hello world, not %. Yep, see, it just runs that as a command. So we're literally just gonna copy the exact same. So we can see that we have git here. So we'll just click git clone -b, which stands for the branch, and we're using the BG branch of this repository here. And then we're gonna copy this link. And then we're gonna set an output. So for Google Colab, all your like read and write operations will go under the /content. So let's just put that there. And then what it's going to do is it's going to clone to the /content. And then now we can run a cd, which stands for change directory, into that. And then we can also run an ls command after. so we can see we're in the right directory. And then now, all we can do is just run the exact same command that we did here, which is Python. Well, first we have to pip install -r requirements.txt or /content/audio/requirements.txt. There we go. So yeah, again, it's gonna take a while. So hopefully it's faster. I think it'll be faster for Meta's, or sorry, Google's. And then if you want to access the stats for like example, like NVIDIA SMI example, you could go here. You can see that the system has 12 gigs of RAM. It has 15 gigabytes of GPU RAM, which is about that's double what I have. And so we can use like the larger model, for example. So yeah, so I'm gonna let that run. I'm gonna pause. I'm gonna speed up the video now. Okay, and then we're back, and then what's going to happen is it's going to make us restart the session, which is basically saying that it's going to restart the kernel, and that's typically when you have an installation of a different version, for example, like this. So yeah, we're just going to press restart session. It's going to reconnect us, and generally it's saying we're going to rerun all the commands, because in a way we're kind of on a new machine, but we're also not. So yeah, we're already on the same machine still, so we can just run this again, and then we can just say, just to make sure that everything's good. And yeah, it says requirement satisfied for everything. It's done. So then all we have to do now is just run the last thing, which is Python /content/audio/main or app.py, and then again, %, this one, and we're gonna do share. So we're gonna run that. It's fine. What's happening? Unable to register. Run! I think this happened to me before. You just have to rerun it again. Saying no files. Copy it right. I swear I copied it right. So go there. They have a, or you can just press that. Let's see. They do that. Huh. Let's copy this, or let's connect. Wait, that doesn't make sense though, because I am already. Oh, okay, guys. So that makes sense because the current working directory isn't changed. So what we actually can do is the % finally, or sorry, oh my god, the % for the CD. I guess that allows us to change the active directory. So if we do this, and then we can run this command. So then now if we run it, it should say our active directory is including that. So we'll run that. Sorry guys. So yeah, it's just this, meaning we're changing the active directory. So the / that we saw in the error message right there, is just saying it's a relative path, and because, yeah. So here we go. I couldn't find that, but now I can. So because we were on Google's computers, not my computer, we can use the more VRAM. So let's copy this exact same prompt here. And we're going to also do like 20 seconds. But this time we can use the large model. Oops. So we can use the large model here, and then let's run that. And then let's press generate. So what's going to happen first is it's going to have to download everything. You can see right here, it's going to take hopefully not that long to download. I mean, they have fast internet at Google, 300 megabytes per second. But yeah, we're just downloading the model right now. All the weights right here. It's about 60 gigabytes. And then after that, we should see, number one, this GPU RAM is going to be increasing, but then we'll also see that this is processing here. I think these computers do have FFmpeg. If I'm sure, or if I remember, they do have FFmpeg. We can check with, what is it? Oh, right, because it has a queue, but you can't run two things simultaneously. Okay, never mind. Okay, cool. So now it's going to be processing. As we can see, it's going to start increasing. It's going to start loading into GPU RAM. We can see system RAM is increasing as well. Yeah, it's just processing now. So you said 20 seconds. Random seed right there. Why is it not? Okay, it's still downloading, it seems. This video's so long already. But yeah, okay, now it's gonna be start loading it. Yeah, so I don't know what that was all about, but it loaded into RAM, but now it's out of system RAM. See, now we're loading into GPU RAM. See, we're using about 7 gigabytes now. And yeah, it's processing through. So this is gonna be continuously increasing, but let's go here. And yeah, the larger model is going to take longer, but as you can see, it actually plateaus here. The RAM actually doesn't increase all that much, but obviously the longer the duration is, the more RAM you're going to use. Well, technically, I could have ran this on my system, no problem, but we would really get close to the ceiling because this is still increasing and it's still only like halfway done. And obviously, for like an actual song, you wouldn't use 20 seconds. I mean, that's so small. Yeah, we're almost done here. Then now it's going to be encoding it. As you can see here with the FFmpeg, it's just encoding it here. And there we go. So we have this, and then let's play. And yeah, that's it, guys. Not that hard. And yeah. Okay, so we're gonna go back to face-to-face. And so, as you can see, we got everything set up, and we can use it both locally on our own computer, or we can use it on someone else's computer, aka Google Cloud. And yeah, that's it for today's video. I'll be going on vacation soon, so I might not upload as much. And remember, guys, we have to use AI ethically and responsibly, and we shouldn't pass off AI generated content as creative content. We have to be explicit in knowing that AI is not a creative process. It's never going to replicate or replace creativity. But yeah, for something like background music, I don't think it's that big of a deal. It doesn't really hinder or affect my ethics personally. If I'm clear with it and just using it in the background. So yeah, that's it for today's video. Thank you guys so much for watching, and hopefully there's going to be more AI content and more programming content, and hopefully some more real life content coming soon. So yeah, thank you guys so much. You guys all have a good day.